Hello and welcome to QuestPon YouTube channel. Myself Gurunatha, a technical developer and a MSBI expert with over 14 years of experience in IT sector. And I am here to present you a MSBI interview questions and answers. And these questions and answers are with the in-depth explanation and step-by-step example. So friends, that's why we have covered only the 5 questions in our part 1 video. Yes, as you can see here, we have the 5 questions which we have covered in our part 1 video. I believe that an individual who have in-depth knowledge for any topic or any question, then he can create a great impact on an interviewer to qualify for next level of round. So these questions are explained with the in-depth explanation and with the step-by-step example. So do watch this video completely. So before we start our session, I want to give away my MSBI ebook, which is in PDF format, from which you can start fully with the MSBI step by step. So how to get this ebook? Share this video in your Facebook, LinkedIn and Twitter account and send us an email, that is at questpon@questpon.com with your shared URL to receive this ebook. So simple as that, So if you have your Facebook, LinkedIn and Twitter account, do share this video with your friends and get my MSBI ebook step by step. So without wasting any time further, let's start our session with the interview questions and answers. So friends, let's get started. ETL process is one of the utmost important interview question. Yes, no matter you are a fresher or an experienced guy, if you don't answer this question, then you can't qualify for the next level round of an interview. No matter you answered all other questions properly. Believe me guys, being into this BI industry with so many years of experience, as a BI guy, I can say that 8 out of 10 times you can expect this question on your table. Yes. So now let's understand how to answer this question. Let me tell you. In data warehousing, ETL stands for extraction, that is extraction, transformation and loading. It is good to start with the full form, but I suggest be more descriptive. Try to elaborate your answer more in elegant and technical way. This way you can stand out with other candidates. The more you present yourself in an elegant and in a technical way, the more you can create impact on your salary. So try to be more creative while answering, try to be more elegant, try to be more technical. This way you can see that you create a healthier impact on your salary demand. Whatever your expectations are there, that will be fulfilled. Now let's continue with our topic, that is ETL process. So in ETL process, furthermore, you can elaborate your answer in this way. That is, ETL process is a 3-step process. That is step number 1. As you can see that extraction is our step number 1. Yes friends. So in extraction what we do? In extraction, whatever the data is collected from the various sources, for example, like we have in this image, SQL server, TXT file, Excel file, CSV file, XML file. These sources can be your multiple sources, yes, or it can be your single source. Single source means, for example, CSV source. Whether you have a single source data, whether you have multiple sources of data, this data, it gets extracted using the SSIS tools. Yes, in extraction, the data from the multiple sources or single sources get extracted. That is the step number 1. Now, coming to the step number 2, that is transformation. Yes, friends. Transformation means, suppose, for example, if we extract the data using the CSV file or Excel file or TXT file, as you know, the by default data type is string only. And this string, we cannot have the same data type in data warehouse. If we want to match this data type with the data warehouse data type, we need to do some kind of data conversion transformation. So that type of transformation we can achieve in the transformation, that is step number 2 process. For example, if we want to do some kind of case transformation, let's suppose I have this name Shiv in lowercase. Then if you want this to be converted into the title case or a capital case, that type of transformation you can do in ETL process. For example, if you want to sort any data, if you want to remove some erroneous data, if you want to remove some duplicate data, redundant data, bad data, if you want to do some kind of lookup, if you want to merge different files, all this type of transformation you can achieve in step number 2, that is in transformation. All this transformation is done using the Microsoft SSIS tools only. So this is the step number 2. Remember that this transformation we do as per the requirement of data warehouse. Whatever is required for data warehouse to dump the data, that all transformation we do in transformation. Now the third and final step, that is the loading part. Yes friends, this is the final step where we get the data which is transformed, where we get the data which is properly extracted, properly massaged. We took that data and finally loads that data into the data warehouse. And this process we do using our SSIS components, that is loading the data to the data warehouse. So friends, this is our 3-step process, that is extraction, transformation and loading. Now on the same, let's see a demo example. As you can see here in this demo example, we are going to extract a CSV file here. Yes friends, you can see that the columns are on the top and the data rows are below. This is a comma separated file. So the extraction will be done on this file. We are going to extract this data. And now for the data warehouse, I have used MySQL Server 2017, as you can see here. And this is the table where I am going to load the data. That is my new customer table. And this is my data warehouse design, as you can see here, with the customer name, customer ID, product purchase, quantity, amount, USD amount and customer visited date with their respective data types. Now let me take you to my Visual Studio 2017 where I am going to demonstrate my ETL process example. The whole point of showing you this example so that you can get a better clarity, you can improve your answer, and I can say that by seeing this example it will be helpful for you for your interview preparation. So as you can see, for step number 1, that is extraction, for this I have used my flat file source component, that is the SSIS component, as you can see here. So this is a component I have used, that is my flat file source component, as you can see here friends. So this is the component I have used. Let me just show you my connection manager of flat file source. So there you go, as you can see friends, I have a customer source dot text, which is nothing but this file. So this extraction I did with my flat file source component here. Let's see the preview. The data preview is here, as you can see. Now for the transformation part, that is my step 2 process. I did a data conversion transformation. Why? As I told you before also, CSV data types are string data types. But in our data warehouse, if you see our data warehouse, we need a different data types, that is money, varchar, integer, date and time, and so on. So for that I have used the data conversion component for the transformation. If you see quickly here, so I did some basic transformation here. As you can see here, the currency is there. I have converted the 4-byte signed integer. I did the date conversion and so on. Now I also did some basic transformation, that is nothing but this case transformation. If you see, my customer names are of lower type, that is lowercase. So what I did here in my transformation, I converted this to uppercase. So let me just show you. Right click on the derived column component, I will say edit, and here as you can see in the expression, I have used the string function upper to convert my CSV customer name to uppercase. Since all my customer names are in the lowercase, so I have converted using the upper transformation, that is upper string function, to convert my data to the uppercase. And one more transformation I have did here, that is my converting the INR amount to the USD amount. So as you can see here, there is a one more column, that is USD amount. As you can see, I have divided the actual amount with the 73. Here I am considering $1 as 73 rupees. So by doing this simple mathematical calculation, I got my USD amount, and this USD amount I am going to insert in my data warehouse on this column, USD amount. So friends, this is what a basic transformation what I did here. Now the final step, that is the loading step. What I did here in the loading step, I just use my SSIS destination component, that is this one, EDO.NET destination. By using this component, I have configured my loading step, that is my final step of ETL process. So let me just show you. I will just right click on this, I will say edit. So here I use the connection manager here, and this is my table name. As you can see here, new customer, and in the mapping I have just mapped my input column, which is properly massaged, which is properly extracted, which is properly transformed. I have just mapped this input column with my destination columns here. So I have mapped all this input column with my destination column, and finally I have successfully completed my loading step process. So friends, this is how I have achieved my extraction using the flat file source component and transformation using the data conversion component and derived column component, and the final step, the loading, I have achieved by using the EDO.NET destination component. Now let me run this program and show you the output. So for that I will just click on the start button to start our program running. So as you can see friends, all the 5 rows has been properly extracted, properly transformed, and finally loaded to the data warehouse using our EDO.NET destination component. So let's check our data warehouse now. So for that, let me just execute this. As you can see friends, all our 5 rows has been properly loaded to our data warehouse. So let's summarize our answer, this whole ETL process answer. That is, ETL stands for extraction, transformation and loading. It is a 3-step process, and it is an important aspect because it consolidates the data from single source or multiple sources and transform it, and finally loads the data to data warehouse. Thus makes it easy for data scientists to access and analyze the data and turn this data into a valuable intelligent information. So this is how, friends, you need to answer for this important question of ETL process. Now let's move on to our next question. SSIS core function to execute packages, and each package consists of a control flow and data flow. Knowing the exact difference between execution of control flow and data flow, it's pretty important. So, if you get this question in an interview, make sure you answer it properly. Now, let's understand how to answer this question. I recommend that you start with the control flow explanation because it is the starting point of any SSIS project package. Then, after this, you can explain the data flow explanation. So, in a package, we can have one control flow and optionally we can have one or more data flow. This is very important line to start because this will put more emphasis on your answer and an interviewer will know that you know the answer technically very well. Now, let's come back to our answer. So if you see here in this example, I have one data flow here. That is nothing but my ETL demo example. If you see, okay, as you can see, this is my data flow and this is my control flow. So if I want optionally one or more data flow, then I can go to my SSIS toolbox. I can drag and drop my data flow task here and I can click on this, and you can see here, friends, I have two data flow here, one for ETL and another one is just an empty. So if you want to execute data flow one or more times, then you can have multiple components like this we have in this example, as you can see here. So it is also proved that we can use multiple data flow tasks in a control flow, and data flow task is also part of SSIS toolbar which is available in a control flow. Now let's talk about the SSIS toolbox. Let's understand the difference between the SSIS toolbox which is available in control flow and data flow. So if you see, friends, we are now in control flow tab, and if I go to my SSIS toolbox, you can see these components here, like the task components, like container components and other task components. These components are more specific to non-ETL activities. If I go to my data flow and if I go to my SSIS toolbox, you can see these components are available which are more specific to ETL activity. For example, extraction you can do from these sources. From the destination you can do the loading, and from the other common components you can do the transformation, massaging of a data. So this is one more difference between the control flow and data flow, the components which are available in SSIS toolbox. Now let's talk about the types of components which are available in control flow. So friends, if you see, we have three types of components available in control flow. Number 1, the task component. Number 2, containers. Number 3, precedence constraints. These are the three types of components which are available in control flow tab. Containers are used if you want to perform any repeated task. For example, looping a files from a folder. If you want to send emails multiple times, then you can use these containers. If you want to perform any repeated task, then we can use the containers. Now let's talk about the second type of component, that is task components. Task components are defined units of work that are performed in a package control flow. Like, for example, we have a data flow task which does an ETL activity. We have a file system task which helps to move a file or a copy of file from one place to another place. we have the script task, which helps to write the scripts and execute the scripts accordingly. We have this execute SQL task, which helps us in writing the store procedures, and so on. There are many such other task components are available in SSIS toolbox. You can use any one as per your requirement. As you can see, we have many other task components are available in SSIS toolbox of control flow tab. Now let's talk about the final component, that is nothing but the precedence constraints. As you can see, this is nothing but the precedence constraints which is available in control flow. The use of precedence constraints is to link between the two executables. So for example, here I have the two data flow tasks. So by using this arrow, I can connect both the executables with each other. It means now this ETL demo data flow task is been connected with data flow task here. So once this is complete, then this will start. So this is the use of precedence constraints, which helps to link between the two executables. Now these are the three types of components which are available in the control flow, that is task components, containers and precedence constraints. Now let's go to our data flow tab and let's see the three types of components over here. So here the three types of components are defined as per the ETL activity. So for example, so if you want to do extraction here, then you can use these specific components. If you want to do any transformation, then you can use all these components which are available here. So if you want to use the loading, then you can use all these destination components. So depending on the activity, these components are defined here. So these are the three types of components which are available in data flow tab of SSIS toolbox. So this is all about the differences between control flow and data flow. Let's summarize our answer. In SSIS package, we can have one control flow and one or more data flow tasks. Control flow is more process oriented, which handles the workflow of execution, like execution of task components and container components. Whereas on the other hand, data flow defines the flow of data from source to destination. Means data flow is more data oriented, which handles the flow of execution. In control flow, you can create logic using components. For example, you can create a logic for fetching multiple files from a folder and passing it to data flow task component one by one for extraction purpose. On the other hand, data flow components are used for extracting the data, moving the data from the source to destination, and also doing the massaging of a data. Massaging here means doing some kind of transformation, merging of data, doing some data type transformation, doing some logical transformation. So in short, control flow is doing all non-ETL activities, which includes email messages, executing a SQL statement, copying a file from one place to another place, or copying a file from FTP server. Whereas on the other hand, data flow is all about doing the ETL activities, which includes CSV file extraction, SQL DB extraction, Excel file extraction, then doing the massaging of a data, transforming our data, and finally loading back the data into the data warehouse. So this is all about the control flow and data flow differences. Hope you liked it. Now let's move on to our another question. As a BI guy, knowing the architecture of SSIS is very important. As a fresher, there is less probability that you get this question. But if you are like 1 or 1 plus above years of experience, then you might expect this question in your interviews. I recommend, no matter you are a fresher or experienced guy, knowing the architecture is very important. If you want to stand out with other BI developers, yes, you must know the SSIS architecture. I believe that a person who knows in-depth nitty-gritty knowledge of any component, any project or any package, then he is one of the best BI developers as compared to other BI developers, or I can say that he is better than any senior developer. Yes. So, how to answer this question? Let's understand it. This is the graphical representation of SSIS architecture, and this image is sourced from Microsoft's MSDN. So, let's understand SSIS architecture using this graphical representation. Friends, for your information, prior to this, that is SSIS, there was something called DTS, Data Transformation Services, in way back in SQL 2000. But it was having with less features, like for example, limited error handling mechanism, limited message boxes, that was too in ActiveX scripts, no deployment wizard, and so on. If you see today's SSIS, then it has powerful BIDS, that is Business Intelligence Development Studio, with proper error handling mechanism, interactive deployment wizard, with wide range of components and so on. So this is very powerful tool. So how to begin your answer? Let's understand. SSIS architecture involves 4 key parts. That is number 1. Let me just show you. The SSIS object model. As you can see here, we have SSIS object model. We have SSIS integration services runtime. We have integration services service. We have data flow task engine. These are the 4 key parts of SSIS architecture. Rest all others, whatever you can see here, that is task, custom task, log providers, connection managers, data flow, source, transformation, destination. All these are part of these 4 key parts only. That is SSIS object model, SSIS integration services runtime, data flow task engine, integration services service. So let's understand these 4 key parts one by one. Let's start with our first key part, that is integration services runtime. So let's start with this. These integration services runtime have 2 parts, that is runtime services and runtime executables. Runtime services includes connection manager. As you can see, it has got connection managers, it has got logging, it has got the breakpoints and so on. The runtime executables like the components, the data flow tasks. To move the data from the source to destination, we have the execute SQL task. For writing the stored procedures, we have the file system task to copy a file, to create a file. We have the send mail task for sending mails. And if we want to perform any repeated task, then for that we have the containers for loop container, for each loop container, we have the sequential container, and also we have some other tasks. As you can see, we have some other task components are available in the toolbox. Remember, these executables are connected via precedence constraints. If you see, this is the precedence constraints. Via this constraints, the executables are connected with each other. So for example, if I want to connect another data flow task, then yes, I can do that via this precedence constraints. When we save an SSIS package, then the components of this SSIS package, it gets serialized to XML and stored in a .dtsx file extension. So let me just show you that. I have saved this package, and as you can see, the package.dtsx file extension is been created under the SSIS packages, and this DTSX file is nothing but a XML file. Let me just show you the view code of this. Just right click on the package.dtsx and you can see the view code of this. Just click on the view code to see the XML code here. As you can see, here you can see the package type, here you can see the connection managers, here you can see the executable file creation date with the name and everything. So this DTSX file is nothing but a XML file here. Now let's talk about data flow task, which is nothing but this one. Data flow task or data flow engine or integration services data flow. The main job of data flow task is to move the data from source to destination. Yes, a source can be a Excel file, CSV file, or any SQLDB file. By using the source components, we can extract the data. As you can see here, let me just show you. These are the source components. By using this, you can extract the data. You can extract any flat file source data or raw file data or Excel file data. Then comes the transformation part. For the transformation also, SSIS toolbox has provided wide range of transformation components. For example, conditional split transformation component, data conversion for data type conversion, merge for merging the two files, and we have the sort to sort the data, and there are many other transformation components are available. Finally, the loading part, the destination part, where we dump the data to the data warehouse. This destination is been handled by the destination components, which is available in SSIS toolbox. Let me just show you. As you can see, we have many destination components here. By using this destination components, we can dump the data into the data warehouse. So this is the role of data flow task, which helps us to move the data from the source to destination. Now let's talk about integration services object model, that is this one. Integration services object model is a managed set of APIs that allow us to write our own custom code, to create our own custom applications by using command line utilities. This object model allows us to use our own custom components to satisfy our ETL needs. For example, we can create a source component that extracts the data from Apache Hadoop DB or MongoDB or MySQLDB or PostgreDB or any databases out there. It helps us to extract the data from any databases. These custom code we can write by using a programming language which is available on CLR, that is Common Language Runtime. Why CLR? Because this whole SSIS architecture works on CLR only, and CLR is the heart of .NET. That's why we need to choose a language which is available on CLR only. So for this example, I am choosing C# as my language. So as you can see, this is my C# language. This is my class library project, and you can see in the Solution Explorer I have referenced some DTS library. By using this library, we can create a package here. We can use the object of package, and we can create the connection. We can name the package, we can set the creation date, and so on. We can do many more stuff to satisfy our ETL needs. The whole process of ETL, which is present here, as you can see, from extraction to destination, this whole process we can write by using this C# code. That's why we have this object model, which gives us the flexibility to modify our project as per our own needs. So this is the role of Integration Services Object Model. Now let's talk about the final key part of SSIS architecture, that is the Integration Services Service. This is an instance of SQL Server database engine, which is available only in SQL Server Management Studio. Let me just show you that. As you can see here, we have this Integration Services catalog. This is a Windows service which helps us to manage the packages, the SSIS packages. Yes, we can deploy our SSIS package projects in this SSIS DB. As you can see, I have deployed one of my SSIS package here in the project section. As you can see, a file system is my SSIS package. Yes. Now I can execute this package directly from here. So this is the role of the Integration Services service. Now let's summarize our answer. That is, SSIS architecture is having the 4 key part, that is Integration Services Runtime, Integration Services Object Model, Integration Services Service, and Integration Services Data Flow Task. The service runtime is useful to create the connection, to run the task components, to run the containers, to connect between the two tasks, and so on. And this executable task is connected via the precedence constraints. So this is the role of Integration Services Runtime. Now comes to Data Flow Engine. The main job of Data Flow Engine is to move the data from source to destination by using the SSIS components, which are available in SSIS Toolbox. So this is the job of Data Flow Engine. That is nothing but our Integration Services Data Flow. Now let's talk about Integration Services Object Model. This SSIS object model is used for programmatically creating and managing the SSIS packages. This object model lets you create your own custom components to satisfy your own ETL needs. So this is the use of object model. Now let's come to the final key part, that is Integration Services Service. This is an instance of SQL Server Database Engine available in SQL Server Management Studio. This is the area where you can deploy your packages. By deploying your packages, you can run independently those packages without the support of Visual Studio. So these are the 4 key parts of SSIS architecture. So this is how you need to explain your answer in an interview. Hope you like it. Now, let's move on to the next question. Answering this question in an interview is very important because this will not only take you to the next level but also give you more freedom to demand for salary hike. Why is that so? If you see in an industry, you will find many BI analysts who can design the data flow using the SSIS component very easily. But only few of them who have a great skill to design the data flow with respect to the performance tuning in mind and who can understand the tuning of SSIS package are very few. That's why it's give you more freedom to demand for salary hike. And that's why it is very important to answer this question. Let me explain you in more detail. The process of designing SSIS ETL package is typically computational. You start with the small sets of components, ensuring that they process properly in a set of correct sequence order. Like we have here a small sets of components. Then sooner or later you add more components or you add error handling mechanism. Like we can add here error handling mechanism here. Then after that, probably you add in more abstraction, that is you will take the advantage of these parameters and variables for runtime changes of package. After doing this whole process, still your work is not yet completed. You need to take some more time to monitor the performance of data flow engine. Why? Because business is likely to change and due to that data too. So today you might have less records. Tomorrow there will be chances of getting higher data volumes, which might cause performance problems like data transformation interruption, memory leakage or data leakage. So friends, to monitor this SSIS package performance, Microsoft has provided us with a set of performance counters. Let me just show you that. So these are the counters which Microsoft has provided us, and these counters are installed on our machine during the SSIS installation. So friends, if you answer this question properly, then I must say you are on the next level. So if you want to be the best BI guy, then you must know these counters properly. So how to answer this one by one, let's understand it. Remember, performance counters of SSIS pipeline type are grouped into 6 groups. That is package execution, this one, blob, yes, then we have buffer, this one, then we have flat buffer, that is this one, then we have private buffers, this one, then we have row performance counter. So these are the SSIS performance counters to monitor the performance. Please remember that these counters monitor and reveal in which way the memory resources are acquired. That is during the execution of SSIS package. And it helps us to determine where the bottleneck situation may be occurring. Now let's understand each counters one by one. So let me just start with the blob, that is binary large object, this one. It shows the number of bytes of blob data that data flow engine reads from all sources. So whatever data is being read from all sources, the count will be displayed here. Now let's talk about the second counter, that is the blob bytes written, that is this one. Remember, it shows the number of bytes of blob data that the data flow engine writes to the destinations. Yes, the number whatever is displayed here will show the number of bytes of blob data that data flow engine written to the destination. Now let's talk about the third counter, that is blob files in use. The number here will be displayed when the number of blob files that the data flow engine currently is using for spooling. Now let's talk about the buffer memory. The value will be displayed here, the amount of memory that is in use. This may include both physical and virtual memory. When this number is larger than the amount of physical memory, the buffer spooled, that is this one, the count of this buffer spooled rises. When this count rises, it indicates that memory swapping is increasing. If that is increasing, then definitely it will slow the performance of data flow engine. So remember that. Now let's talk about the next counter, that is buffers in use. Remember, the value of this buffers in use will be displayed when the number of buffer objects of all types that the data flow component and data flow engine are currently using it. Yes. Now let's talk about the buffer spooled. You can see the values of the buffer spooled when the number of buffers written to the disk. If the data flow engine runs low on the physical memory, then these buffers which are not currently in use are written to the disk and then reloaded when it's needed. Yes, so this is about the buffer spooled. Now let's talk about the flat buffers. That is this one, the flat buffer memory. These are large blocks of memory bytes. Yes friends, flat buffers are the blocks of memory that a component uses to store the data. And this data is stored in a memory of bytes. And this data is accessed byte by byte by a component. And the values comes here when any component stores a data in a flat buffers. Flat buffers in use. This counter sets when the number of flat buffers that the data flow engine uses. And remember, these flat buffers are private buffers. Now let's talk about private buffer memory. This counter sets when the total amount of memory is used by all private buffers. Yes friends. And remember, these private buffers are buffers that a transformation component uses for temporary work only. Okay. So now let's talk about our next counter, that is private buffers in use. This counter sets when the number of buffers that transformation uses. So whenever you see a transformation component uses a buffer, then this counter sets. Now let's talk about our another counter, that is the row read counter. Yes friends. And this counter sets when the number of rows that a source produces. Remember, the number does not include row read from the reference tables. For example, the row read which is generated by the lookup components. So that number does not include in this row read counter. So only those values will be presented which the source produces. So this is about the row read counter. Now let's come to the row return counter. The number of rows offered to the destination, that value is set in the row return counter. Remember friends, this number does not reflect the row returned to the destination data warehouse. Only those numbers are selected, only those numbers are presented here in this counter which are offered to the destination components, not the rows offered to the destination data warehouse. Remember friends, that is the difference. The number of rows written is counted here, which are offered to the destination component, not to the destination data warehouse. Yes. Now let's talk about our last and final counter, that is SSIS package instance. Remember friends, this package instance comes under the SSIS service 14.0. So this counter shows up when the current number of simultaneous SSIS packages running together. Yes. So friends, this is all about the performance counters of SSIS package. Now on the same, let me just show you a simple example. So here in this example, what I will do, I am going to demonstrate a SSIS ETL example. So here in this example, what we will do, let me just show you. So here I have my ETL package. Okay. So if you see, so my complete package is ready here to run. So what I will do, I will run this package. Okay, at the same time I am going to open up my performance monitor, and there I am going to add this counters, and simultaneously I will run this package and show you how the values reflect in that counters. So let's demonstrate that. So for that, let me just open up my performance monitor. So for that I will type here as a performance monitor. So there you go. The screen is here of performance monitor. So let's go to the reports, and I will add here counters, and I will say SQL, and here I am going to add this SSIS pipeline 14.0 and SSIS service 14.0. So I will add both the counters. I will say OK. So there you see the counters are came, that is blob, bytes, buffer, flat buffer, row reads, and so on. So what I will do, I will run my SSIS package, and I will just show you how the values are reflected here in this counter. So let's do that. So I will just do the build here first. So build is succeeded. I will just say start. So there you see my package is started running, as you can see on the left hand side, and there you can see the values here, right? So how the buffer memory came here and how it went, and again the rows read, can you see, and the rows written. So this is how friends we can monitor the performance of SSIS package. So friends, this is about the types of performance counter in SSIS. So if you get this question, make sure that you answer this question with the types. That is, we have the blob bytes read, we have blob files in use, we have flat buffer, we have private buffer, we have row reads, we have this SSIS package instances, and so on. So make sure you answer these types of performance counter of SSIS, and also you elaborate these counters as we have just seen in this video. So now let's move on to the next question. SSIS has so many properties that some are overlooked or ignored. Yes friends, this lookup cache is one of the most overlooked property. Many of us just ignore the settings and simply continue with its default setting, that is full cache. But hang on, this overlook property can become one of your interview question. Yes friends, and an interviewer will not overlook this question. He can put you this question on your table anytime. So be prepared for this question. As you can see friends, here we have a simple ETL program. Yes friends, here I have a flat file source where I am extracting the data, and here I am doing some transformation, and here you can find a lookup also in the transformation part. Yes. So let me just right click on this, edit. As you can see, we have the three cache modes here, that is full cache mode, partial cache mode and no cache mode. Remember, the lookup cache selection will determine how lookup values are cached during the package execution. Yes, so whatever the selection you do here, it will affect during the package execution. It is critical to know how cache modes affect the results of lookup and the performance of the package. Yes, so whatever the cache mode you select, it will definitely affect the performance of a package. So it is very critical to know the caching concept. So friends, before we go further and understand these three modes, that is full cache, partial cache and no cache modes, let's understand the caching concept. So let's understand that. So friends, this is the working of lookup component, where the lookup has stored some data, that is the data set, and for each record, if the value exists in cache, okay, then a cache memory comes into the picture, which is a temporary storage of data, and from there the lookup will happen. Once the lookup is successfully found, the output is provided here, as you can see. If the value is not exist in the cache, then this value goes further to the data warehouse. Yes, and it makes a query to the data warehouse table for the lookup of a data. If the match is found here, the output will happen here, and the same output will get stored in the cache memory also, so that when the next time the same value comes, then instead of going to the data warehouse lookup, it will directly look up from the cache memory. Okay, so remember it, caching is like a high speed temporary storage data, and it is available so that the data can be accessed more quickly and thus helps to reduce the load on the data warehouse server. Yes friends, so now that you have understood the fundamental of caching memory, let's go and understand the lookup caching now. So as you can see, let me just right click. So now to answer that, the types of cache mode available in the lookup transformation editor is this, that is the full cache, partial cache and no cache. These are the three cache modes available in the lookup transformation editor. So let's understand all these three one by one. So starting with the full cache mode. Full cache, this is the default setting in lookup component. Yes friends, so if I do the cancel here and if I click on the lookup component and do the edit like this, then you can see that the full cache mode is by default selected. Yes, as the name says, full cache, it caches the entire data set into its memory. Before the package starts execution, it caches everything. So it is recommended that you should use this mode if the dataset is smaller than the source data. So it means that this data should be, that is the table which we have selected here, that is the country table. The data which is present in the country table should be smaller than the source data, that is the flat file source, which is the source data. Okay, so it means that lookup data set should be smaller than the source data. So if you have this scenario, then it is better to go with the full cache mode. If your data set is larger than the source data, then it is better to use the no cache mode. Yes friends, consider the situation in which your input data is having 100 records, that is this scenario where our input source data is 100 records and our dataset records are 100k. Then Using the same with the full cache mode means SSIS will load the full 100k records into the memory and then performs the lookup for package execution. All this just to look up 100 values. Is that a best practices? To do like this? I say no. In such scenarios, that is in this scenario, you can use no cache mode. So it is better to use the no cache mode in such scenario. So every time we should not go with the default setting of the lookup component, that is the full cache mode. So depending on the scenario, you can change these modes, that is partial cache mode or no cache mode or full cache mode according to the requirement. Now let's talk about no cache mode. As the name says, here the dataset will not be cached into the cache memory because there is no caching here. It will not cache anything. Whatever the request comes in, it will directly send it to the data warehouse. And data warehouse will cater that request accordingly. So whatever the request comes from the source side, it will directly send it to the data warehouse for processing the request. And the data warehouse will process that request directly. So I feel it is one of the best settings to have when your input data is smaller than the dataset or when you want to disable the cache mode. If you see our previous example, no cache mode solves all the problems. That is this example where our input source data was 100 records and our current dataset records were 100k. So in such cases you can directly go with the no cache mode, which solves all our problem. Now let's talk about the third and final mode, that is the partial cache mode. Partial cache mode is like a hybrid mode of other two. Partial cache mode means the value from the input source first checked into the cache memory. So that is whatever the value comes in, it first checked into the cache memory. If the value does not exist, then it queries to the reference data warehouse and get the value from the data warehouse, and before outputting it saves one copy to the cache memory. Why? So that when the same request comes again, instead of querying to the data warehouse, it just queries to the cache memory and gets the value as an output. So this is the use of the partial cache mode. Okay. So when to use this mode? When your reference dataset is large. When your reference dataset is large and your source data set is small, then you can use this mode. So now you will be wondering that the same thing we can use it for no cache mode also. The same example was applicable for the no cache mode also. No friends. So if you see here, let's consider the same example, that is our source data is having 100 records and our reference data set is like 100k. Now if you see, we have made some changes here in this example, in this scenario. Basically, yes, we have the 100 records from the source side and we have the 100k records from the dataset, but the unique combination value from the source side is just 10 only. The unique values out of this 100 are 10 only. Yes. So if we use the partial cache mode here, then it will process only the 10 queries, which is perfect solution to this scenario. So here if we use the no cache mode, then it will process all the 100 queries to the data warehouse, which is again not a good idea, not a best practice I say. So in such cases, you can use the partial cache mode where it will process only 10 queries, which is a perfect solution to the scenario. Yes, so only the 10 times it will queries to the reference data warehouse, and the reference data warehouse will store one copy to the cache memory, so that when the same request comes again, the cache memory will cater that request. So that is the benefit of using the partial cache mode. That's why I told you it is the hybrid mode of other two, that is a full cache mode and the no cache mode. So concluding all this, using the correct cache mode for the job can have a huge impact on the package performance and server load. So it is very necessary that you use the proper cache mode. So without the proper selection, you cannot improve the performance of a package. So friends, this is all about the lookup cache mode. Hope you liked it.